In this video, we're going to take what we've learned in the past 3 videos and we're going to mix all of the transformation types together and write functions that contain all different types of transformations. So before we jump in and actually start writing these, I just want to do some reminders for you. Remember that the shifts are your movements. So if we have a vertical shift, that's going to be impacted by the variable k, which is being added outside the parentheses. And if we have a horizontal shift or a horizontal movement, that is being added inside the parentheses. And that's going to be the opposite of what we expect. So keep that in mind as we're working. That's how our movements work. Then from here, a vertical shrink or a vertical stretch. Remember, that's when we take the entire function that we have and we multiply it by our a value that we're given. That's our vertical shrink and our vertical stretch. So we have y equals our a value times the entire function, and this is where we had to do some distributive property. Then from here, our horizontal shrink, we dealt with a b value, but remember that b value was calculated by taking 1 over the factor that they gave you. So that's like if you get a factor of 1/2, you do 1 over 1/2 and calculate what your b value would be. And once you have that b value, you simply take your inputs or your x values and you multiply x by that b value. Then for a reflection over the x-axis, this also kind of does deal with a and b, but it's just dealing with negative ones here. And if you have a reflection over the x-axis, remember that's this horizontal line here, so this is going to be flipping it vertically. That's where we take y is equal to, you multiply the entire function that you have by -1. And if you have a y-axis reflection, so it's reflecting horizontally, you simply take your x value and multiply that by -1. So we'll be using all 6 of these topics today as we perform multiple transformations on different equations. So example 1 here we can see is a part of the quadratic family. And what we're going to do is we're going to write a function g whose graph is vertically stretched by a factor of 3, then reflected over the x-axis, and then shifted right 3 units. So we have 3 different transformations going on, and we're going to do each one in order. So the first thing that we see is that our whole graph is being vertically stretched by a factor of 3. So this is going to deal with an a value. And from there, what's going to happen is it's going to take our entire function and multiply it on the outside by that a value. And because this is a vertical stretch, this a value is simply equal to the factor, which is 3. So we're going to go to our equation here. We have g of x is equal to, we're taking this entire function here, so we have 2, then in parentheses 3x plus 4 quantity squared minus 5, and we're going to take that entire thing and multiply it by our a value of 3. Remember, it only gets distributed once to each chunk, so this 3 multiplies by the 2, and then by that 5. So our function at this point is 6, because 3 times 2 is 6, and then in parentheses 3x plus 4 quantity squared minus 3 times 5, which is 15. Then from here we're going to reflect over the x-axis, which is a horizontal line, and as a result that results in a vertical flip because you're flipping it vertically over that line. As a result of that, we have y is equal to -1 is going to be on the outside, and we're going to multiply our entire function by a -1. So here we're going to take this function that we already have, and we're going to multiply it completely by -1 in order to flip it over the x-axis. And again, we only multiply each chunk once. I'm going to utilize keep change here so I don't make an error. So I multiply the 6 by a -1 as well as that -15. So here I have -6 in parentheses 3x plus 4, and then -1 times -15 becomes a positive 15. Now the last thing that I need to do here is I need to shift the graph to the right 3 units. So we know that if we're shifting the graph to the right, that's going to impact our h value. And if we think about it, moving to the right is moving in the positive direction, and we know that h works the opposite of how we typically move. So if we're moving to the right, we know that we're going to be adding a -3 into our equation. Now, remember, when we add this value in, we actually need to add it directly to x, which means we need to surround x with parentheses and then subtract 3 from it inside of those parentheses. So here, I'm just going to rewrite it so it's a little bit easier to look at. So I'm putting parentheses around my x. I'm subtracting 3 from x to move it 3 units to the right. I then include that plus 4, have my parenthesis with my squared, and then my plus 15 on the outside there. So at this point, we now need to work on simplifying what is inside of these parentheses. So I'm going to shift all my work up just a smidge, and I'm going to simplify what's inside of there. So I distribute my 3, so I have 3x minus 9 plus 4 all inside of those parentheses. And then from here, I see that I can combine -9 and 4 to be -5. So I end up inside those parentheses with 3x minus 5 quantity squared plus 15. So example 2 here says write a function g whose graph is reflected over the y-axis, then horizontally shrinks by a factor of 2/3, and then moves down 4 units. So I'm going to start this whole process by rewriting this function so that I can see where the h value might go. So I have -4 in parentheses x plus 0 minus 5. So now this is ready for me to manipulate. As a result, we're going to go and we're going to first start with the reflection over the y-axis. So remember, the reflection over the y-axis is going to be a horizontal reflection. And as a result, we're just going to multiply that x value by -1 on the inside. So we're just going to put a -1 on the inside there. So we have g of x currently is equal to a -4 parentheses -1x plus 0, and then the -5 on the outside. Now, from here, we have a horizontal shrink by a factor of 2/3. So this is telling me that I need a b value because I'm going to take my x value and I'm going to multiply it by that b value. And b is calculated by taking 1 over my factor, which is 2/3. So I can turn that into 1 divided by 2/3, then multiply by the reciprocal of the second one. So my b value becomes 3 over 2. So I'm going to go in here and multiply x by 3 over 2. Now what I'm noticing here is that x already has a coefficient of -1. So I'm going to have to multiply -1 times 3 over 2. And luckily that's a pretty easy multiplication because it's just -1. So -1 times 3 over 2 simply becomes a -3 over 2. So here we have -3 over 2x. You can leave the plus 0 in there if you would like, and then the -5 on the outside. So we've now taken care of that horizontal shrink by a factor of 2/3. Now the last part here is to move down 4 units, and that is going to utilize k, and it's going to subtract 4 on the outside of the parentheses. Now, in order to ensure that I don't make any mistakes, I am going to just use keep change here because that's a pretty easy flip. So we're going to do -4 and -5 added together, so that becomes -9 on the outside here. The rest of the problem remains unchanged. You can write the plus 0 in here if you want, or you can take it out. It doesn't really matter because you don't need the 0 anymore. But what you should see at this point is you have now reflected that graph over the axis. That happened in blue at the beginning where we added in that -1. Then you horizontally shrunk it in red by finding that b value to multiply your x by. And then in green you moved it down 4 units by adding that k value of -4 on the outside. And last example here, it says write a function m, so we're mixing up the letters here, whose graph is vertically shrunk by a factor of 3/4, horizontally stretched by a factor of 3/2, flipped over the x-axis, moved up 2, and then finally moved left 6. So this one is going to have a lot of different transformations taking place. So let's start with m here, and start with the fact that it's vertically shrunk by a factor of 3/4. So this means that we're going to be dealing with an a value. So we have y equals a times our entire function on the outside. So I'm going to take this current function of -2 absolute value 3x plus 5 then minus 4, and I am going to vertically shrink it by a factor of 3/4 by multiplying it by 3/4 on the outside. So I distribute the 3/4 to this first chunk, so it multiplies by the -2, and to the second chunk, so it multiplies by the -4. So here I have 3/4 times -2, and I'm going to put that over 1. So that becomes -6/4, which becomes -3/2. So this first piece here becomes -3/2 on the outside. The 3x plus 5 remains untouched on the inside. And then 3/4, I'm going to use keep change here quick, times -4/1. That becomes -12/4, which becomes a -3. So then we have a -3 here on the outside. So I've taken care of that first vertical shrink by multiplying the entire function by 3/4. Then this next part says a horizontal stretch by a factor of 3/2. So remember, with a horizontal stretch, we're just going to multiply the x value by our b value, and our b value is calculated by taking 1 over our factor, which is 3/2. So this is 1 divided by 3/2, which is 1 times the reciprocal here, which is 2/3, so it becomes 2/3. So our b value here is 2/3, so that's going to go in here and multiply along with the 3. So we have to do some more fraction multiplication here, so we have to do 2/3 times 3/1, which becomes 6/3, which is 2. So after that horizontal stretch is performed, what we're left with is -3/2, and then here we now have 2x plus 5 minus 3. Now the next step here says we're going to flip it over the x-axis. I'm going to make some notes here. So that means I'm flipping it over this line, which means it's a vertical flip, which means I'm going to multiply the entire function by -1. So essentially what I'm going to do is I'm going to take this whole function and I'm going to multiply it by -1, which means I'm going to multiply this coefficient here by -1, and then I'm going to utilize keep change to make sure I don't make an error and multiply this number here by a -1. So we end up with positive 3/2, then we have 2x plus 5 inside the absolute value, and then -1 times -3 turns that -3 into a positive 3. So notice that the a value out in front as well as the k value both flips to become positive as a result of that reflection. Then from here we're going to move up 2. So that's an addition of 2 to the k value, which is on the outside of the function. So we're going to add 2 on the outside. These two added together become 5. So we have 3/2. Keep the rest the same, then we have plus 5. And finally, the last thing that I need to do here is I need to move this graph to the left 6 units, so I can see that right there. Now, I know that moving to the left impacts my h value, and I know that that movement to the left 6 is in the negative direction. Because it's moving in the negative direction, I need to remember that h works the opposite of what I would expect. So we're going to be adding a plus 6 to the inside with x. So we're going to surround our x with parentheses, and we're going to add 6 to it. Now, it looks a little confusing being written in that way, so I'm going to add a little bit more space here. So I have 2. I then have my x with 6 being added to it directly inside, and then I have my plus 5 outside of that. My absolute value closes, and then another plus 5. So now I know that I have shifted this graph 6 units to the left by adding this plus 6 right here. So the last thing I need to do is I need to simplify this piece that is inside of the parentheses. So I start by distributing, so I have 2x plus 12, then plus the 5 there. And then the last thing I need to do there is I need to simplify this chunk right here by combining like terms. So inside of those absolute value symbols, I have 2x plus 17. Then I have the 3 halves in front, the plus 5 at the back, and there is my new function.